Hello students, this is Dr. A.Y. Khan from Dharwad. Today I will be dealing with electrochemistry. In electrochemistry, we will come across some calculations related to electrode potential. We will also deal with calculation related to cell potential or EMF. Even we'll see how to calculate the equilibrium constant, molar conductivity of a solution. Electrochemistry is a branch of science that deals with the interconversion of electrical energies and chemical energies. A galvanic cell is a cell that converts chemical energy into electrical energy. A galvanic cell consists of two electrodes. At one of the electrode, oxidation takes place. At another electrode, reduction takes place. The electrode where oxidation takes place is called as anode, and the electrode where reduction takes place is referred as cathode. Then what is an electrode? An electrode is a metal in contact with the solution of its own ion. When metal is in contact with the solution of its own ion, the potential developed is called as an electrode potential. Electrode potential is tendency of a metal to gain or to lose electron. The tendency of a metal to lose electron is called oxidation potential, and the tendency to gain electron is called as reduction potential. Electrode potential of a single electrode cannot be determined. It can be determined by connecting with reference electrode. Generally, hydrogen electrode is used as a reference electrode. Nernst gave an equation between electrode potential and ionic concentration. And by using the Nernst equation, you can calculate the electrode potential. And the equation goes like this. For a reaction Mn plus n electron giving M, electrode potential is equal to standard electrode potential. Standard electrode potential is potential measured under standard condition, that is at a temperature of 298 Kelvin and when the concentration of the ion is 1 molar. Standard electrode potential minus 2.303 RT divided by NF log of concentration of metal divided by the ions. For pure solids or liquids, concentration is equal to unity, hence the equation gets reduced to standard electrode potential minus 2.303 RT divided by NF log of 1 divided by concentration of ions. At a temperature of 298 Kelvin, 2.303 RT by F. R is gas constant, T is temperature in Kelvin, and F is Faraday, that is equal to 96,500 Coulomb. So 2.303 RT by F at 298 Kelvin is equal to 0.059. Hence the equation at 298 Kelvin gets reduced to electrode potential is equal to standard electrode potential minus 0.059 divided by N log of 1 divided by the concentration of the ions. Students, let's discuss some problem related to electrode potential. What is the electrode potential of iron electrode in which concentration of ferric ions is 0.1 molar? Given standard electrode potential is equal to plus 0.771 volt. This can be calculated by using the Nernst equation, and according to the Nernst equation, electrode potential is equal to standard electrode potential minus 0.059 divided by N into log of concentration of ions, ferric ions. In this equation, the value of N is equal to 3 because Fe3 plus gets reduced to Fe. So for reduction of Fe3 plus to Fe, we require 3 electrons, and in this case N is equal to 2. Hence electrode potential is equal to standard electrode potential. The value is given 0.771 minus 0.059 divided by 3 into log of 1 divided by the concentration of the ions. And concentration of ion is 0.1. 0.1 can be written as 10 to the power minus 1. If it goes to the numerator, it becomes equal to 10. So hence this can be written as 0.771 minus 0.059 divided by 3 log 10. log 10 is equal to 1, hence this will be equal to 0.771 minus 0.059 divided by 3. On simplification, the value will be equal to 0.75 volt. Hence, option B is the right answer. Students, let us discuss another problem related to electrode potential. The potential of hydrogen electrode having pH is equal to 10 is option A 0.59 volt, option B minus 0.59 volt, option C 0 volt and option D minus 0.059 volt. This can be calculated by using the Nernst equation. Hence, electrode potential is equal to standard electrode potential minus 0.059 divided by n into log of 1 divided by the concentration of H plus ions. In this case, N is equal to 1, and for hydrogen electrode, the standard hydrogen electrode potential value is equal to 0. Hence, the equation gets reduced to 0 minus 0.059 divided by n into log of 1 divided by concentration of H plus ion. This can be written as log of 1 by H plus is equal to minus log of H plus ion. Hence, I can write it as minus into log of H plus ion, minus into minus will be plus, and the equation gets reduced to 0.059 divided by 1 into log of H plus ion. So we require H plus ion concentration, but H plus ion concentration is not mentioned. Instead, they have mentioned the pH values. pH is equal to 10. pH of a solution is minus log of H plus ion concentration is equal to 10 minus the other side. So hence, log of H plus ion will be equal to minus 10. Friends, we require log of H plus value, and log of H plus value is equal to minus 10. So this can be substituted here. Hence, this will be equal to 0.059 into minus 10, that will be equal to minus 0.59 volt. Hence, option B is the right answer. Electrode potential is tendency of a metal to lose or to gain electron. Tendency of a metal to gain electron is called reduction potential, and its tendency to lose electron is called as oxidation potential. Oxidation potential as well as reduction potentials can be measured, but IUPAC recommends the use of reduction potentials only. Reduction potential of zinc electrode is minus 0.76. and reduction potential of copper electrode is plus 0.34. Higher reduction potential value indicates that a particular element undergoes reduction easily. So out of zinc and copper, copper has a tendency to gain electron or to undergo reduction. Oxidation potential of zinc is plus 0.76. Oxidation potential of copper is minus 0.34. Higher oxidation potential value indicates zinc tendency to undergo oxidation is more as compared to copper. Oxidation potentials and reduction potentials have same magnitude, but they have different signs. Arranging the reduction potential in increasing order is called as electrochemical series. With the help of the electrochemical series as well as with the help of reduction potentials and oxidation potentials, we can predict a reducing agent, we can predict which element undergoes reduction easily, as well as even we can predict the activity of an element. Student, let us move with the next question. Four metals A, B, C and D have standard reduction potentials of minus 3.05, minus 1.66, minus 0.40 and plus 0.8 volts respectively. The metal which is most easily reduced is. So as discussed earlier, reduction potential gives you the tendency of a metal to undergo reduction. Higher the value of reduction potential, higher will be its ability to undergo reduction. If you compare the values, metal A has a reduction potential value of minus 3.05, metal B has a reduction potential of minus 1.66, metal C has a reduction potential value of minus 0.40 and metal D has a reduction potential of plus 0.8 volts. Out of all the four values, metal D has highest reduction potential values, hence it undergoes reduction easily. Hence option D is the right answer. Student, let's move on with the next question. The question is, standard reduction potential of zinc ion, chromium ion, H plus and ferric ion are minus 0.762 volt, minus 0.74 volt, 0 volt and plus 0.77 volt respectively. Which is the strongest reducing agent? Option A, zinc ion, option B, chromium plus 3, option C, H plus, option D, ferric ion. A reducing agent is a substance that reduces the other and gets itself oxidized. So out of the following, we should find the metal ion which undergoes oxidation easily. So what we can do is convert the reduction potentials into oxidation potentials. The one with higher value will undergo oxidation easily, so that it will be a good reducing agent. How to convert the reduction potentials into oxidation potentials? Reduction potential and oxidation potential have same values, but they have different signs. For example, Zn plus 2 has a reduction potential of minus 0.762 volt, hence its oxidation potential will be plus 0.762 volt. Reduction potential of chromium is minus 0.74 volt, hence its oxidation potential will be plus 0.74 volt. Reduction potential of H plus 0, oxidation potential also will be 0. Reduction potential of Fe3 plus is plus 0.77 volt, hence its oxidation potential will be minus 0.77 volt. Now, once you know the oxidation potential, the ion with higher value of oxidation potential undergoes oxidation easily, hence it acts as a better reducing agent. So out of the four options, Zn plus 2 has higher oxidation potential, hence it is a good reducing agent. Electrochemical cell or a galvanic cell converts chemical energies into electrical energy. A galvanic cell consists of two electrodes. At one electrode, oxidation takes place. At another electrode, reduction takes place. The electrode where oxidation takes place is anode, which is negatively charged, and the electrode where reduction takes place is called as cathode, and it acquires a positively charged. The two electrodes, the solution of the two electrodes will be connected through a salt bridge. The two metals will be connected through a metal wire. Electrons moves from anode to cathode. EMF of a cell can be calculated by the formula EMF of a cell is equal to E of cathode minus E of anode. That is, it is the difference between the reduction potentials of cathode and anode, or you can write it as E of positive electrode minus E of negative electrode. Nernst equation also can be used to calculate the EMF of a cell at various concentration. For a reaction A into A plus B into B giving C into C plus D into D, according to Nernst equation, EMF of a cell or cell potential is equal to E naught of cell minus 2.303 RT divided by NF log of concentration of C raised to C, where C is the stoichiometries, D raised to D divided by A raised to A and B raised to B, where small a letters A, B, C and D are the stoichiometries. For a Daniell cell, if you consider a Daniell cell consists of two electrodes, one zinc electrode, other one is the copper electrode. Zinc acts as an anode and copper acts as an cathode. Hence, for Daniell cell potential is equal to E naught of cell, where E naught of cell is standard electrode cell potential, minus 2.303 RT divided by NF log of concentration of zinc ion into concentration of copper divided by copper ions into zinc. The concentration of pure metals and solids are taken as unity, hence concentration of Cu and zinc will be equal to 1, hence the equation reduces to E naught of cell minus 2.303 RT by NF log of concentration of zinc ion divided by concentration of copper ion, or to remember, we can remember it as log of concentration of ions at anode divided by the concentration of ions at cathode. Cell representation. There are certain rules for representing a cell. While representing a cell, anode is always written on the left hand side and the cathode is written on the right hand side. The phase difference is indicated with the help of a vertical line. The salt bridge present is indicated with the help of a double vertical line, and the metals are written at the extreme ends. For example, consider a reaction, net reaction that is occurring at a Daniell cell. In a Daniell cell, zinc loses electron and copper gains electron. Hence, at a zinc, oxidation takes place. Hence, zinc is an anode or a negative electrode. Copper gains electron. Hence, copper is cathode or a positive electrode. While representing a cell, negative electrode or anode is written on the left hand side and positive electrode or cathode is written on the right hand side. In Daniell cell, zinc is anode, so zinc electrode is written on the left hand side and copper on the right hand side. The vertical line indicates the phase difference. Zinc is in solid state, whereas ions in the aqueous phase. Similarly, a phase difference here also indicates that copper ions are in its aqueous state and copper solid state. The double vertical line indicates the salt bridge. Let's discuss the next question. The question is, cell reaction for the cell Zn bar Zn2 plus salt bridge cadmium 2 plus ion bar cadmium is given by. The four options are given to you. This is a cell representation. Whenever we represent a cell, always anode is written on the left hand side and cathode is written on the right hand side. Hence, zinc electrode acts as anode, cadmium electrode acts as cathode. At anode, oxidation takes place. That means zinc loses electron. So, the reaction occurring at zinc is zinc loses electron to form Zn2 plus. Cadmium acts as an cathode, hence cadmium ion accepts electron, Cd2 plus 2 electron giving the cadmium. Cell reaction is sum of these two reactions, hence the net reaction is zinc plus cadmium ion giving cadmium. Hence, option D is the right answer. Students, let us discuss the next question. Calculate the EMF of the cell. Cell representation is given. We have provided with the standard electrode potential values of copper electrode as well as the silver electrode. We need to calculate the EMF of the cell. Option A is plus 0.46 volt, option B plus 1.14 volt, option C plus 0.57 volt, and option D minus 0.46 volt. EMF of a cell can be calculated using the formula. EMF of a cell, that is E naught of cell, is equal to E naught of positive electrode minus the E naught of negative electrode, or E naught of cathode minus the E naught of anode. Out of the two electrodes, the positive electrode can be determined by the values that are given, and even you can determine by the cell representation also. Negative electrodes are always written on the left hand side and positive electrode is always written on the right hand side. So hence copper should be negative electrode and silver is the positive electrode. Based on the values also you can distinguish which is positive and which is negative electrode. The electrode with high positive value will be positive electrode. The one with lower positive value will be the negative electrode. If both are negative, if both the values are negative, the electrode with higher negative value will be negative electrode and the one with lower negative value will be considered as the positive electrode. Here both the values are positive, whereas silver electrode value is higher as compared to the copper electrode. Hence silver is positive electrode and copper is the negative electrode. Hence EMF of a cell is equal to E naught of positive electrode, that is silver electrode, 0.80 minus E naught of negative electrode, that is copper, 0.34 volt. So if you simplify, you will get 0.46 volt. Hence option A is the right answer. The next question is, the standard reduction potentials of lead and zinc electrodes are minus 0.126 volt and minus 0.763 volt respectively. The EMF of the cell representation is given, the concentration of the ions is given. Options are 0.637 volt, option B less than 0.637 volt, option C greater than 0.637 volt, and option D 0.889 volt. Since concentrations are given, the EMF of the cell can be calculated using the Nernst equation, and the Nernst equation is EMF of the cell is equal to E naught of cell minus 0.059 divided by n into log of concentration of ions at anode divided by the concentration of ions at cathode. You can decide which is the anode and cathode based on the cell representation. Here zinc acts as anode and lead acts as cathode. Hence it will be log of concentration of zinc ions divided by the concentration of lead ions. To calculate the EMF of a cell, we should know the value of En as well as E naught of cell. E naught of cell can be calculated by the standard reduction potentials. E naught of cell is equal to E naught of positive electrode minus the E naught of negative electrode, and N can be calculated based on by writing the cell reaction. The cell reaction will be zinc acting as an anode, hence zinc loses electron to form Zn2 plus, that will be accepted by lead ion to form lead. In this reaction involves the use of 2 electrons, hence for this reaction N will be equal to 2. Hence E of cell is equal to E naught of cell. E naught of cell is nothing but E of positive electrode, E naught of positive electrode minus E naught of negative electrode minus 0.059 divided by N into log of concentration of zinc ion. Zinc ion concentration is 0.1 divided by concentration of lead ion, lead ion concentration is 1 molar. This will be equal to E of positive minus E of negative. So both the values are negative. If both the values are negative, the higher negative value indicates that is a negative electrode and less negative value indicates it is a positive electrode. Hence it will be minus 0.126 minus of 0.763 minus 0.059 divided by 2 into log of 0.1. 0.1 can be written as 10 to the power minus 1. On simplification, you will get the value equal to 0.637 minus 0.059 divided by 2. Log of 10 to the power minus 1 is minus 1 log 10 and log 10 is equal to 1. Hence, log of 10 to the power minus 1 will be minus 1 into log 10 where log 10 is equal to 1. Minus of minus will be plus. Hence, the value will be greater than 0.637 volt. Hence, option C is the right answer. The next question is, for a reaction at 298 Kelvin, the reaction is given. Kc has been found to be 10 to the power 12. The E0 of cell is. There is a relation between E0 of cell and Kc, and the relation is standard EMF of a cell is equal to 2.303 RT divided by NF log Kc. At a temperature of 298 Kelvin, 2.303 RT over F will be equal to 0.059. Hence, the equation gets reduced to 0.059 divided by N log Kc. The Kc value is given to be 10 to the power 12. To calculate the EMF of the cell, we need the value of N. N can be calculated by using the reaction. A gets converted to A2 plus, that means A is losing 2 electron. So hence N will be equal to 2. Or else you can calculate from this ion also. 1B plus accepts 1 electron to form B, 2B plus will accept 2 electron to form 2B. Hence N will be equal to 2 in this reaction. Hence the value will be 0.059 divided by 2. Log of 10 to the power 12. Log of 10 to the power 12 is 12 log 10, because log of a raised to x is x into log a. Log 10 to the power 12 is equal to 12 into log 10. Log 10 is equal to 1. Hence, this will be equal to 0.059 divided by 2 into 12. 2 ones are 2 6 are. If you simplify, you will get the value equal to 0.354 volt. Hence, option A is the right answer.